Hi everyone and good afternoon. This is my physics video project for Mr. Roden's SI 141 Spring 2017 class. My topic for this video project is shooting your basketball from the free throw line to the basketball hoop. My topic is similar to what we've already learned on Chapter 3 on projectile motion. The scenario is a projectile launch in motion at an angle. Here's a visual that I drew of the scenario. We don't know what the shooting angle is, the shooting speed, and the shooter's height. And at the bottom, we also don't know the distance from the free throw line to the basketball hoop. So here's what I found. First, I found the shooting angle to be around 50 degrees to make the basketball to the hoop. Next, I found the shooting release position to be over the head just right above the height level. The height of the shooter is 6 foot 6 inches. I converted the height from feet to meters, which equals about 2.0 meters. Lastly, I did a test speed of 4.0 meters per second for the basketball's initial velocity at release. By finding the initial velocity and angle, we can now calculate the Vy initial and Vx initial to determine the rest of the unknowns. Since we have determined and calculated a few unknowns, the next step is to list what we know and what we don't know. We know that the x initial and y initial equals 0. We still don't know what x is, but we found y to be negative 2.0 meters. The Vx initial equals 2.571, which we solved above, and is also the same as the Vx. The Vy initial equals 3.064, while the Vy is a known. Acceleration in the x direction equals 0. Since the basketball is falling down vertically, we have an acceleration on the y direction of negative 9.8 meters per second squared. What I want to know is, how long will the basketball be in the air after the release from the free throw line to the hoop? I use the kinematics equation on the y direction to solve for time. The formula is y equals y initial plus Vy initial time plus 1/2 ay time squared. I plugged in the values and got a quadratic problem. Then I used the quadratic formula to solve for t. Doing all the calculations, t was approximately 1.0239. By rounding off, time equals 1.0 seconds. Here's a video that I had based my calculations and measurements on. In this video, it shows the shooter shooting a free throw from the free throw line to the hoop. I also recorded data and I timed the shot while I watched the video. The video shows my results and how long the ball was in the air. My calculation shows that the ball will be in the air from the release to the hoop for about a second. By finding time, we can approximate the distance, and with our velocity, we can calculate the distance of the basketball hoop to be around 4 meters, which is approximately 14 feet away. The usefulness of this project is to determine the time and speed of the ball that will reach the distance to make the shot inside the hoop. By shooting the ball at the speed of a second at an exact distance of 4 meters from the free throw line to the hoop, the ball will reach the shot.